Hi everyone. As you might have already read from the title today, I'll talk a little bit about... there we go. I think Georg came up with the title. He just randomly suggested Git advanced usage. And yeah, I think, at least I hope I can maybe give you a bit more advanced usage tips. I don't know, we'll see. But I'll try to kind of connect it to hopefully existing knowledge that you have with Git, because really everybody uses Git. It's a version control system, if you want it or not. Let's say you have some research project, some software that you want to clone off of GitHub. Well, I mean, you have to use Git. So most of you have probably used it already, possibly to a different extent. Like maybe you just kind of use it to get along. Some of you may use it more extensively. And today I want to show you a bit more like how can you use its features so that it gets less in your way, which I think is really what's making an advanced user, so that you don't get confused by it. So you probably have seen these commands before, at least I hope so. So let's say you want to clone a repository, you want to pull from it to get updates, you want to add a file to it and commit it and push it. This is kind of the very basic thing that people know about Git, and you can get quite a far way with it. But some of the things you may have recognized, but you may not really understand what it is, and this is kind of what I'm trying to tell you. So you might have heard of the staging area, or perhaps not, or what exactly history means in Git, or what, for example, the ref log is, which is something very useful, which I'll come back to later. And I promise you this won't be a theory lesson today, but I mean, we'll go over some of the technical details of how Git functions internally. That gives you a better understanding of why certain things behave in a way. So I thought it would be a good idea to kind of start with a few errors or unexpected situations in Git that you might have come across. Maybe something confusing like this, or head detached, maybe you've seen it before. What on earth does that mean? Or, you want to do a git pull and it's saying, please commit or stash your changes because otherwise they'd be overwritten. Okay, maybe you found your solutions around that, but we'll get back into more of the details later. Merge conflicts. I mean, everybody loves it and everybody hates it, of course. So why do we have it, and how do we get along? You want to push something and it doesn't work for some reason. Like if you read through the text, you might already get an idea, but this is kind of the thing that I want to aim at, that perhaps after this talk, when you read a message like that, you'll have a better understanding of what is the next step in order to resolve the situation. Or things like, there's no tracking information for the current branch. What does that mean? I hope I can kind of catch your attention a little bit with these situations that you might have come across. So I really try to boil it down to what makes an advanced user. It's really about having solid fundamentals, because if you have solid fundamentals, you can read Git error messages, you know what they mean, and then you can kind of start to look up the right things. And once you know how to look up the right things, things get really, really easy. For me, that's being an advanced user. So let's start with the first thing, Git history. I mean, it's hopefully obvious that we're not talking about the history of the development of Git itself. What does Git history mean? Well, it is, of course, a history of commits. So a commit is basically just a change that you bring into a Git repository, into a version control, just as a logical step that you can return to later and have a look again. Why is it relevant that we have it? Well, I mean, I already said it. You can use it to look back in time. You can use it for debugging. For example, you've run into an error and you don't know where it's coming from, and you can use the Git history to kind of look back and see, this was maybe 1 week ago when we did this and that, and this is basically what it's useful for. And from there, I'm kind of concluding it should hopefully be as easy as possible to look back into the history, because I think this is really what it's like. Running into bugs and finding out where things went wrong is really, I think, the most common thing for me, at least when I use Git, at least apart from all the boilerplate like pushing and pulling. And what makes it easy to look at the history, we'll have a look later, and maybe then you'll have a better idea. Some of the things that make Git history a bit more interesting, for example, to something compared to like SVN, is that you have a nonlinear history, as in that you, yes, for the people who know what it is, a direct acyclic graph history. So you can basically, I mean, you may have heard of, or you will have heard of branches. You can branch off of your history and kind of basically connect it in all the ways imaginable. And this will introduce situations when you want to, that are problematic when you do a rebase or a merge, that you run into a merge conflict, which I've already shown you in that screenshot before. And this of course makes things a bit complicated. Yeah, this is perhaps one of the special things about Git. So I'm just trying to cover some basic examples here, just so we are all on the same page. So you may have seen these funny hashes there before. When you create a Git commit, you have this hash that kind of represents a certain state of that repository. And if you do a commit, well, you kind of get a new commit. And they are chained after one another. And you could say each commit has a parent because, well, that was basically the version before. And so let's do a few things. For example, this. Oh, what happened here? So as you might see, on the lower left, do I have a mouse cursor? Yes. On the lower left here, these two things appeared. Origin head, origin main. What on earth is that? Well, I can spoiler that. Well, we did a git push for the first time, which basically means that we now have a remote, which I'll explain more later, origin, which can be something like GitHub or GitLab, for example, where we now have our main branch. And what these yellow boxes here, essentially, they are just pointers to commits. So like a branch that you have is essentially just a pointer that points to a commit hash. And it's really nothing else than that. So you have your main branch that points basically to the last commit that you created. Head is a bit special. It's not really a branch, but it's basically just telling you, oh, this is the branch that we're currently working on, because you can, of course, switch between multiple branches. And this is relevant when we, for example, branch off at a certain point in history. For example, we have this feature branch A. And, well, in that case, if we're now working on that, our head changes. And I hope that during the talk, I can also explain you some of the terminology, because you might have probably seen something like head, but don't quite know what it means. Yeah. So we are creating this feature A branch, doing some work on it, and we eventually want to bring it back into our main branch. And what do we do? Well, we do a merge. Depending on how your workflow is used to, you might have done pull requests on GitHub before, or merge requests on GitLab. And this is kind of basically the same thing, but you don't have to use these platforms to do a Git merge. You can just do it locally. And this is basically what I try to show here. The Git merge is a bit special because it creates this commit that has two parents. And I'll get into a bit more later why this is can be problematic. Of course, because you can get merge conflicts, but it also means that it's not always easy when looking at a merge commit what happened before it, because you have kind of these two ways branching off. Oh, the difference between those two is just that we push the main branch once again, and for us locally, it basically just changes two pointers. Now, when going through the slides, initially I already noticed that I was running a bit low on time. I have, in principle, here a few examples on how you would reproduce this graph before. I'm not sure if you want to go through all of it in all the detail. I mean, maybe I can go over quickly. I'd say it's mostly useful for the people who want to go over the recording and maybe reproduce it. I don't know. So basically, we create a directory, go into a directory, and we type git init. Maybe in the past you've created a repository on GitHub and type git clone. That's one way of creating a repository, but you don't have to use GitHub or GitLab or anything else. You can just create a folder and type git init to basically get starting with a Git repository. It's just a different way of doing it. You can create a file with some content, create a commit, and we basically, on the slide before, we did that 3 times, and that's basically just what I'm doing here. The commit hashes will differ for you because, well, they're based on all kinds of funny information like your email, your name, and your time, and the commit before. That's also quite important, which means that if you change the commit, if the commit were different before your current commit, then all the resulting hashes will change. What we did here is for the pushing, for the initial push is that we add a remote. As I've mentioned, I will explain remotes, what those are exactly in more detail later. But we create a remote, which is basically just a different site where we can communicate with to the outside world. For example, GitHub, like I've done in the example here. And we can push to that remote. Simple as that. We can branch off of this. I mean, there are multiple ways you can do it. Maybe this example is rather academic, and maybe this is not exactly how you do it, but unfortunately, I did the animation before I did the way how to reproduce it. Maybe that was not the smartest idea. So maybe I'll skip over this part here, but basically we create a branch of some random commit in our history before and add some changes to that. And at the end...
Sorry,
yeah.
Question? So I do the git switch 18.2d0,
yeah.
then I create a branch,
yeah.
which means usually I wouldn't be able to change this commit 182d0 because it's
yes.
fixed in time, it's over.
Yeah, right.
But now, since I created a branch, I can do development from this point on.
Exactly. I mean, strictly speaking, you can still do development on a raw commit, except that once you change away from it, it's lost. But, well, it's not quite lost. We'll get into more details with Revlog later, but... And this is, by the way, a situation of detached head, because I've mentioned this head thing before, which is it's telling us where we currently are, and we can manipulate head to show onto a commit that isn't part of a branch. And this is kind of what we're doing with this git switch here. And the first time you see it, it looks a bit scary, but it really isn't. It's just telling you, hey, you don't have a branch, and if you do stuff, maybe you shouldn't do it, because if you switch away from it, it will be lost. So what we do here instead is we create a branch immediately, and then we can do changes to it normally. And in order to merge it back, well, we switch to the main branch and we merge our feature branch A. As simple as that. And then again, we can push it to our remote. Now, any questions so far? Yeah, whoever wants first.
I was wondering what's the difference in checkout and switch?
Well, switch is a bit of a newer thing, and that was introduced because the meaning of checkout is a bit ambiguous at times, because it switches branches and it restores files. And so they introduced git switch in order to git switch and git restore in order to differentiate that functionality. But you can also use git checkout.
But for git checkout, you have to sometimes also change the upstream, right?
Yeah, you'd have to give me more details on that, I think.
I mean, I don't know how it works with switch. Do you have to change the upstream every time?
Well, I mean, first of all, you don't really need an upstream at all when you don't want to push. So, and in case of feature A, we don't push it, so we don't care. At least in this example. Yeah, so, you first?
I learned to use always the -a flag git commit -a, and I tend to tell that users, okay, it's easier to do the -a. Is this silly?
Well, I'd have to, honestly, I don't use it because I don't do commits like I showed here. Well, not quite like that. So you'd have to give me a hint on what -a does.
It prevents asking things. So it prevents maybe my guessing. I'm not sure whether it's true. It prevents the staging magic.
I think it's automatic. It's an automatic add all changed files.
Oh, well, I mean, I probably wouldn't do it. Possibly because of something that I'll explain later, which is that you actually review your commits before you actually create them. And this is where the staging area comes into context, which I will discuss separately later. Yes?
I'm kind of wondering, in which location would you encounter the reset problem? Like you need to do either a soft or hard reset to get everything on track.
We'll talk about that later. I have a separate slide for that, yes?
So set upstream is basically this where you do the push origin master or main or whatever it's called.
I have a separate slide for that also.
Yeah, because it wasn't the previous one and it wasn't quite.
Yeah. It's a good question that you ask it, but it's sometimes a bit difficult to come up with a good order for all the slides and to talk about all the things. And hopefully at the end we maybe can come back and see if there are any unclear things. Okay, so same example again, but this time I'm introducing something that you may or may not know, which is called rebasing, which is basically just, well, I mean, the word rebase already kind of describes what it does, is that it puts your commit onto a different base, which is basically just a different parent. So it's don't over-interpret this meaning or this word. What it basically means, rewriting history or changing commits that have already been there. And what exactly does that mean? Because with git rebase you can do many things, and I'll try to do the simple things first. Okay. For example, one of the this example starts out the same as the last one, so we have these 3 commits. We push it, and we create a second branch. Now, one of the things that you may encounter, which I'll also show later in an example, is that you run into a Git history that has very many merge commits. And these sometimes make it a bit unclear, like what happened in your Git history. So there's an argument to be made of, wouldn't it be kind of cool to avoid these merge commits? And one way of doing it is you doing a so-called rebase. And in this case, what we want to do is that we want to rebase this commit 1707 that we have in the middle here, not on the 182DO commit anymore. We want to rebase it onto D7, DD8 or onto main because, well, main is a bit easier to remember. So what does that mean? Well, if you rebase, we kind of do this. We push this commit that it now is based on this other one. And if you've paid attention, you might have noticed that this commit hash of our feature A branch has changed, like between these 2 slides. And this is, well, an unfortunate thing that we have to live with because, well, each commit hash represents itself, the commit itself, and the past history. And if we change the past history, which we've done because we've changed the base commit, then our hash changes. And this has some nasty implications. But in this case, it's fine. Yeah.
Is the old hash still there? So could I go back to it? Or is it?
Well, I mean, yes, I'll talk. This has to do with the git ref log, which I'll talk about later. So there are ways to restore it, but usually it's better to save it on a different branch before you start your rebase, because otherwise it's a bit more difficult to restore. And the ref log doesn't save you every time. So yes, well, you should treat it like it's gone, yes. So if you mess up with your rebase, you can kind of screw up your Git repository.
Is it correct to say that the commit that I did before that I rebased, it's now as if I had done the commit on D7, DD8 instead of 182, D7?
Exactly. And when you do this, you can run into the same situation that you run when you do a merge, which is a merge conflict. Because, well, now your diff kind of represents a different point in time where, for example, if here, like if there's a function A in this commit over here where the mouse cursor is, and you edit it in both of these commits, well then, of course, when you want to rebase it like that, and you both have edited the same functions, you will need to resolve like this conflict, which you will usually do within a merge. But since we are not doing a merge here, you have to do it when you do the rebase. But yeah.
Sorry, why would we want to do that? Isn't that a little bit defying the purpose of the Git history in the first place, to be able to check out the development of the repository? Why would I want to rebase?
Because it makes your history easier to read. And when you look at a merge commit, it's not always clear what has happened before. And I'll try to show a better example later. Because if you have a linear history like you have here, you see exactly, oh, this is how it was before and this is how it was after. And if you have a merge, there is not always clear before because you have these 2 ways branching off. And the nice thing that we now have here is that when we do a merge into main, we don't really have to do anything. And this is also called a fast forward merge, where we basically don't really create this merge commit. We just pretend, oh, this was just regularly committed on this branch. And we can do that, well, because there are no conflicts to be made, well, because we don't have 2 parents. And now, of course, the question is why we do it. Okay, but now we have avoided doing a merge commit. And I also have some slides here that go through basically through the same example. I've skipped the first steps because they're essentially the same. But when you are on this, yeah, go ahead.
Okay, so the rebase pertains to all the commits in the branch, not just the last one.
Yes, it does. Well, yeah. For example, if you have done multiple commits here on feature A, it will rebase all of the ones that are on feature A and put them on top of main.
But in the course of that rebase, there could be conflicts as well. When
Yes.
in branch something happened. Then
Yes, and the evil thing is that there can even be sometimes more conflicts. But this is kind of a trade-off that you make in regarding to having a nicer history and having to resolve more conflicts. Usually not too common to, I mean, it's a bit difficult to construct cases where you'd have conflicts to resolve multiple times, but especially happens if you have multiple commits that you have to rebase. Because essentially what you have to do is that you have to push every single commit from each commit to the next, and during each move, yet you can run into conflicts. So basically what you do if you're on feature branch A, basically what you just do is that you say git rebase main, and that's doing the one step where you move that connection from one commit to the next one. And then you basically just switch back to main and merge it. I don't think this -- fast forward only flag is required. I think it depends on your Git configuration, but I had it in here just to make an example.
And what does it stand for?
Sorry?
What does it mean?
This is the fast forward merge, which I think briefly mentioned previously, which is what you could do here is if you want to merge feature A into main, is create a merge commit regular. But in some cases you don't need that because, well, essentially you can just treat feature A as a normal commit and put that into main because you don't have the situation where you have two parent commits. Does that explain it? Or?
I think so.
Okay. Yeah. So, I mean, we've already touched some of the topics previously. So, why rebase at all? Or one thing that I haven't mentioned is that some project maintainers, for example, if you want to contribute to a different project, they will ask you to do so because, for example, it's part of the policy that their history is as clean as possible. And another thing is, of course, when you want to create a pull request on GitHub, then GitHub for the project maintainer may tell them, oh, there's a merge conflict, and whoever has created this pull request has to resolve these conflicts. And there are, of course, two ways of resolving these conflicts. First is, for example, let's go back to this example here. If you were to wanted to merge feature A back into main, and there was a conflict, one way of resolving this conflict would be first merging main into feature A, and then via the pull request merge feature A back into main. But this kind of creates a situation where you have this kind of redundant merge commit before. And so this is why some project maintainers will ask you to do a rebase so that you only have this one final merge commit when they click the merge button on GitHub. So this is one of the reasons why you want to do it. I mean, I mean, of course, it's not a reason on itself, but at some point you have to accept it that certain projects have certain policies. And one way is it avoids future merge conflicts simply because you have to forcefully resolve these conflicts when you do the rebase. And I think this is what I touched briefly when we were talking, is that it avoids these opaque merge commits. And what does that mean? Well, because if you look at a merge commit, which we'll do in a little bit, you won't really see a diff or anything. You will just see, oh, stuff has changed, but you don't really see what has changed. And sometimes when you do a merge commit, even though it doesn't have any merge conflict, it will still produce non-functional code. And this can be, well, this is like if it causes a syntactically correct program, for example, but a semantically wrong program. And if you rebase your code before putting or merging it upstream, then you can be sure that the version that you test locally will actually work. Because, well, then you only have to do a fast forward merge upstream. And yeah, basically what it does is it creates a clean and linear history, which is easier to read. then let's come to the reasons why do you not want to do a rebase. Well, you may run into the situation where you have to resolve a merge conflict multiple times, or merge conflict is possibly the wrong term because it's more like a rebase conflict, but it's essentially doing the same thing. And that can be more work, especially if you have a very big project and very many commits that you have to rebase. Then it's really an argument to be made that it's not a good idea to do a rebase. And the other big reason is you have other people that are working with your branch. And it basically means everything that is upstream and other people are using or are supposed to use, for example, your main branch, don't rebase your main branch. Don't rebase that because, well, if they are working on it and if they want to get updates from you, they won't be able to do that anymore because you have destroyed their base commit during the rebase. So don't do that. So here, now I'm trying to show an example and give some brief overlook how these merge commits or these rebases may look like. So let's start first with Liquid. I'm demonstrating a tool here, which I'll explain more in a moment, which is useful for looking into the history of Git, which is tick, which basically just Git reverse. And this, for example, the Liquid history, where I've been done early January, I've been doing some work. And up there, you like on the left, you see like date information, and in the middle, you have this quasi graph that shows you, okay, we had where these O's are, this is where a commit was made. And down here, oh, okay, there was apparently some kind of different branch that was then later merged up here. And for example, and this is, by the way, why tick. It now gives me an overview of the commit here. And if I look at this merge commit, it doesn't really show me a diff here. I don't really know what has been done in this merge commit, which is a bit why it's sometimes difficult to look through what has actually happened during this merge. Now, if you look through each of these branches themselves, then it's quite easy to read. You have these commits where things have changed. Okay, easy so far. But these merge commits can be a problem. Now, in case of Liquid, I'd say it's mostly fine because there are not too many diverging graphs, as you can see. Like, I mean, of course, you perhaps don't have a reference yet, but I'll show you a different example where it's possibly a bit worse. Like occasionally you merge stuff into here. Okay, that's fine. Let's, for example, have a look at CC backend, which some of the colleagues here will recognize. And here, for example, you can see things look a bit more cluttered, where you have like merge commits kind of all the time, like here, 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 here. And like if you want to go over here, it's not always clear, like, for example, this commit, on which base was this actually really being worked on? Because in parallel, as you can see from the purple graph on the left, there was something going on in parallel, but so basically what I want to tell you is it's not easy to see which changes at which time were already upstream. And now you may ask, of course, like, why are even these merge commits there in the first place? And it's unfortunately the text is a bit too big here than some. But for example, you can see here merge pull request. Okay, that looks understandable. But for example, this is I have to make the text a little bit smaller. What you will see here is merge branch def of will into def. Okay, I merged def into def. What on earth happened here? And the same thing here again, merge branch def into def. The same thing here, like, where are all these merge commits coming from? And this is kind of what I'm trying to bring your attention to is the following. Do you know what a git pull does? And so, well, I mean, of course, that's a bit of rhetoric here, but what it actually does is, at least by default, it does a git fetch, which is basically just getting all the data from your GitHub repository, GitLab, whatever, and then afterwards it does a git merge for you. And this is where all these merge commits are coming from. And this is kind of maybe where I can convince you to change a setting in your git config, which is to do a rebase on a git pull. Because most of the time, when you do a git pull, all you really want to do is just get the latest stuff from upstream, and you don't really want to create an explicit branch because, I mean, semantically you would create a branch for, oh, you're developing this new feature and then eventually you're going to merge it back. I mean, that's of course fine, but most of the time you just have this single commit that you're pulling. Does it really need an extra branch? And at least my argument is most of the time not. So what you do here is that you change Git to do a rebase when you pull. And what it does is essentially every time you pull, it does a rebase instead, and that retains the linear history when you do a Git pull, which I at least find very useful. This is why I give this as a recommendation today. Okay, I mean, I already briefly showed Tick, which is, by the way, a very useful tool. Unfortunately, it's not available in the cluster. But if you're working on your laptop, I mean, there are other graphical tools that you can use. And I suggest, even if you don't like it, maybe look into some other graphical tools that you can use to look into the history, because it gives you an idea kind of what are all the things that are currently going on. Especially, I mean, if you're working alone on the project, it's perhaps not that exciting. But especially if people are creating branches and you want to kind of see what's going on, or just even for linear history, it's also fine that you can see, oh, what did I do a year ago? Maybe it's interesting to you, I don't know. And so if you don't have Tick available, you can also do this. And if that's too much to type, you can create an alias in your shell, or I think you can also set in the Git configuration, you can like create your own Git command essentially, where you can abbreviate that. So I was already showing you how to kind of move these commits with a rebase on top of one another, but you can do much more with a rebase, which I won't go into detail today, because you can really do a lot of things with it. You can edit and fix commits, you can delete commits, you can insert new commits in your entire history or wherever you want. You can merge, you can split commits, and that's essentially how it works in theory. I'm not going to show you all the details today. Is you just say git rebase -i, which means interactive. Oh, please rebase everything up or down to this commit ID here. Or you just say head ~8. By the way, if you don't know this syntax, this head ~8, we already learned what head is. And tilde and a number basically means just take this commit and go by that number of revisions back, which is sometimes useful. Otherwise, you can also use a tool like Tick, and on the lower right, you can see the commit hash here. You can copy that in order to get the right commit hash to use for your rebase. And what it would look in theory like is that then opens an editor for you, where you have actually you have an editor pre-filled out with commits and instructions for you how to actually perform this rebase. Like down there, you can see that certain words that you can use up here to do operations on your existing commits. For example, you could say, oh, I want to edit this single commit. Then you write edit here, you close the editor, and Git will do all the things. It will rewind back to this commit. You can edit it, and then you can continue rebase, and then it will apply back all the previous commits. Yeah, but as I say, it's an advanced thing. I unfortunately don't have time to go into all the details of it today. But maybe if you're curious, you can try it on your own. Now, one very important thing is, oh no, something bad happened. This is already something that you have touched on. I messed something up. What do I do? There's multiple things that you can do. If you're still within your rebase and you're unsure, or you just want to go back where you were before, you can just type git rebase abort.
What do you mean I'm still within my rebase? I try rebase and it says it's a conflict?
And for example, that, or there is some type of other different error message. And the other thing is, of course, you can type git status, and if it's telling you there's a rebase ongoing, then that's the case where you want to do it. The other thing is, by the way, this also works for git merge. If you ever run into this situation, and if you don't know anymore what to do, you can just type git merge abort. That also works. And now the interesting question is, of course, your git rebase is already done, and now you have a commit and realized, oh, I've accidentally deleted a commit, or I've applied a change to it, and now it's gone. What do I do? You can use the git reflog command to recover deleted commits, which is a very handy tool. It has its limitations. But what you do is you use git reflog to get a list of all the previous commits that were made. And this really, I can show you an example here. Okay, that doesn't work on this machine because I haven't actually done any work here, which is a bit unfortunate. But usually you would get a long list of commits here that you've done in the past. And this does not refer to commits on that branch. This really refers to individual commits that you've done regardless of the branch. Yes, there was a question.
Yeah, what does ref in reflog stand for?
Reference. So a log of references. And what this essentially allows you to do is to go through this log and find your old commit hash where your state was still good. And then you can use that in combination with git reset hard to get back to this, to reset your branch to that state.
So is it correct to say that git reflog is like git log, but only show my commits and show all my commits across all branches?
Well, you could say so, yes. And there are some limitations because these deleted commits that are not referenced anymore anyway, they eventually expire and get garbage collected by Git. I'm not sure exactly when that happens. I think there's like a certain time that has to pass. You can also manually trigger it, but usually there's not much reason in doing so. But if you ever run into a situation where you have deleted something, let's say 2 weeks ago, and you're unsure if the recovery is still possible, what you should do is, first of all, copy your entire folder with the Git information to somewhere else just so you have a backup, because if you run the wrong Git commands, it might do an implicit garbage collection and then your reflog is gone and you cannot do the recovery anymore. So if you're unsure, copy it away and then perhaps ask someone who knows how to solve it or how to recover it without deleting the reflog. Another common thing that you might run into, this is a bit of a cut now here between the previous slide, but often the thing that you might run into is you've done a commit, and well, you could use a rebase to now kind of commit something else and then merge it to the previous commit. But a different thing is that you can just do is to do an amend commit, which basically just means update the previous commit instead of making a new one. Just one of those handy tools, I'd say. If you've run into the situation where you wanted to create a commit and I don't know, how do I cancel it? Just leave the commit message empty and Git will exit. If you use git commit -m, well, then you can't do that, but I'll tell you in a bit why you shouldn't use it. Which is exactly here right now. I suggest that you use verbose commits, because this just gives you a very handy, at least when you're using Git on the command line, because it gives you a very handy opportunity to review your commit or all the things that happened in a commit. So what does a verbose commit do? Oh, and this is kind of in combination with -m, because if you use -m, you don't get the editor fully opened with all the text information, because a verbose commit looks a bit like this. It opens your regular editor, and at the top line, you enter your commit message, and perhaps if there is something more interesting happened in your Git, you write a second paragraph. And the special thing about the verbose commit, instead of just the editor being blank at the bottom, it gives you a full overview of your commit. And I find this, at least from a command line user perspective, I find that very useful, because I can just scroll down and see, oh, there was this line that was changed. Oh, okay, that's part of my commit. Let's perhaps edit my commit message a bit. And sometimes I realize, oh, there's something in the commit that I didn't mean to be in there. And then I can just delete the commit message, close it again, and edit my commit before I continue. At least I found this to be very useful. I mean, I'm open to discussion, of course, if you disagree. Yeah. As for Git history, my conclusion wants to be like, yeah, don't be afraid of rewriting and rebasing your history. Just don't do it if your work is already public, because people are going to get mad. Okay, any questions about history? I know I have many slides today, but I hope the other ones won't take as long. Yes.
Yes. I'm just wondering whether and why I want to invest as much time in having a clean Git repository history. The whole point of this is to actually help me develop my software. And I've been told the main reason for Git is so easy to branch and merge all the time. Now you're telling me don't merge. You want actually to rebase. And I'm just a bit trying to figure out, Do I really need this, and why should I invest all this energy into making a beautiful history?
I guess it depends on the project. And for example, if you're just working on your own, I mean, nobody's going to care, right? If other people are involved that don't really know anything about Git history, well, maybe then no one is going to care either. The reason I'm trying to tell you is because it makes debugging sometimes easier when you have to rewind back into the history and find bugs that were done like a year ago, or I don't can even be just a couple of weeks ago. It makes you appreciate a clean history a bit more. And I can understand if that doesn't entirely convince you. Maybe that's just the type of point where you have to be in the situation in order to understand it. So yes, of course, some people kind of overdo it a little bit, and maybe this is a bit too much. Yeah, you don't have to worry that much about it. I showed the CC backend example, of course, a bit not to mock my colleagues, of course, but who work with me on Cluster Cockpit, but to show it as a way of maybe like the git pull rebase option setting that is very easy, and it's most of the time not going to impact you much, and it's already making your history much easier, and you don't really have to do anything else. And about all the other things, well, I mean, it's up to discussion, I'd say. Does that answer your question?
I have to admit, I didn't quite get the git pull thing, because if I do git pull,
Yeah.
will it always create a new revision, a new commit?
Well, it depends. Git pull, if it can fast forward, which means that you don't have any local commits done that were not yet upstream, then it doesn't do a merge commit.
Okay, I see.
But if you have done work locally and that's already in a commit, then it will create a merge commit.
Okay, yeah, makes sense.
Yeah. Okay. So if there are no more questions, I'm going over to. Oh yeah.
Maybe I know a little bit less about the merge.
Yeah.
But I was wondering, you said if rebase avoids having future conflicts.
Yeah.
But I thought if you don't look at the history, then the merge and rebase look the same, and at the head.
Maybe let's go back to the example. I'm not sure if that makes it easier to explain. So maybe can you repeat or?
So one question is, after rebase and merge, the branch still exists.
Yeah.
And so then you have the head at the end after both a rebase or a merge. So this commit, this last commit would look the same. How does it avoid or?
You mean like because the resulting commit will look, as in file contents, will look the same, or?
Yes. Yeah.
I mean, yes, of course. I mean, this is purely meta work in the way, because you just care about history. You don't really care about the history of the file itself. But the thing is, if you just look at the file, it doesn't tell you anything about its past. And this is where rebasing comes into. And I mean, of course, it's a bit academic, this example here, because it, I mean, maybe afterwards we can find a better example where it would make more sense. I'm not sure if that answers your question.
Yeah, maybe if you go to the slide with the advantages of, or why you should use.
Yeah.
Avoid
future merge conflicts, yes.
That was a bit.
Oh yeah, and that's very easy. I would say let's put it this way. When you perform this rebase here, you possibly have to resolve conflicts because you move this commit onto a different base, and this means there's a different state where this diff applies. And for example, I mean, I've mentioned previously to you, if both these revisions edit the same function, then of course you'll have a conflict when you do this operation here. But once you are here, you can basically integrate this into main without having a merge conflict at all, because you have already dealt with the problem. This is kind of the idea.
But if you would do a merge instead, then it's the same.
Well, you still have to deal with the conflict, that's true. But for example, if you use a platform like GitHub and you want to merge a pull request, I think there are some ways to resolve merge conflicts on the web GitHub UI, but it's probably quite painful to use, and you cannot really test your changes in your web UI. So I wouldn't suggest you do that. And the easy way is that you, at least for me, is that you rebase locally. Then you, of course, have to locally deal with the merge conflicts, and then you are sure that the merge or the pull request on GitHub will work flawless.
You're making stuff that happens remotely happen locally.
Yes, exactly. Okay, then let's go over to the staging area. This is hopefully a bit easier to understand. Of course, you want to commit stuff. So what you do, well, you type git app and you do git commit. But so where does the staging area come into here? And some version control systems don't really have that concept. I mean, you're here for learning about Git, not about something like SVN, because honestly, nobody really uses SVN anymore. But there's kind of an idea behind it. And this is that the staging area gives us a concept that allows us to choose the things that we want to commit. And this is sometimes useful because, for example, what I often do is, when I work on Liquid, is that I edit a configuration file that changes which features are enabled. And then I work on these features, but I don't really want this config file to be committed because I want these features to be per default off, but I still want to work on my own features. So I only want to commit some things, but not all things. And this is where the staging area comes into play. And if you type git status, you might have seen something like this before. I tried to come up with this example here where you can see all the different combinations. Okay, there seems to be a file whose changes are to be committed. Then there are changes not staged for commit, and there are completely unchecked files. And you can even run into the funny situation where you have something like this, and I'm not sure if you have some good eyes that see what's going on here, where you have a modified file, my file that's staged for commit. No, we have my file too, which is staged for commit, but it's also marked as modified. So what's going on here? Like if we type git app, you would, for example, expect it to become staged for commit and not be unstaged for commit. So what happened here? I'll talk about this in a moment. But this is just one of the, I'd say, useful features of Git where it allows us to even very precisely, even within a file, to select single lines which we want to stage for a commit. For example, when we have a debug statement in a file that we want to leave in, but we don't want to commit it, there are ways to put these into the staging area. Because only stuff in the staging area will be committed. And to better understand what the staging area actually is, it's basically just this column all the way on the right. And how do we move from these different states to one another? Well, if we have an unchecked file and we type git app, well, it becomes staged for commit. You may know that. And I've highlighted these commands in bold, which you have probably used before. Also, if you already have a file under your version control, you can edit it, and then it will first become modified, which we've seen on the slide before. And then you can once again type git add to mark it staged for commit. And then when you actually commit a file, well, then you once again move back to the unmodified state because, well, then there are no pending or no uncommitted changes. So these are kind of the most common things that you use. And I'm not sure who has asked that before about the git reset hard and soft and all that before. Okay, that will be in the next few errors. Anyway, another special case is if you delete a file and you just say git rm -- cache, which means retain the file in the file system, but please remove it from the history. Well, then you can actually have a situation where you'll move from the state from stage to untracked, but that's a rather special case. Something more practical would be something like git reset, which you may or may not have used before, which basically means, well, discard everything in the staging, but leave the files otherwise unchanged, which makes them essentially modified state again. Then there's also the reset hard, which is a command that probably does too many things at once. But one of the things that it does is that it basically discards everything that you've done since your last commit. And this is why I tried to highlight it in red. Sometimes it's useful to do it, but be careful with it because it will delete stuff. And the git reset soft, honestly, I don't particularly use it very often. What it does, it kind of undoes a commit. and it moves the changes back into the staging area. Maybe there's some use for it if you've accidentally committed something that you didn't mean to commit, then you can use git reset -- soft. But at least in practice, I personally don't use it very often. Yes?
So can you actually get that from git reset hard? Like you mentioned that you will lose something, right? But at the
Yes.
git reset soft at one. Is this something that takes you back from?
Oh, well, I mean, in this case, the graph is perhaps a bit misleading because, well, it just means the git reset -- soft only undoes an already existing commit. And the git reset -- hard, well, it brings you back to you have pending changes to, well, you delete these changes. So you can really, I mean, the arrow directions are a bit misleading because they only technically bring you backwards, not forwards, if that makes sense. Yes?
What's the default reset mode?
Mixed. Which is, I didn't know that before making the slides, so I looked it up. But yes, if you just type git reset without anything, that is the -- mixed mode, which is the one that you see here with the mouse cursor is.
Okay, because usually when I have to go back to modified state and remove the commit as well as the state files, then I use git reset head -1. So mixed mode, but pointing to the head.
Well, you can also do that, but I mean, this syntax can do more, I'd say. Like you can. I'd have to check. I don't know that off my head. Because I'm not sure what would happen if you say git reset head ~2 or something like that. I'd have to look that up. Okay, so I just thought it would be kind of funny to visualize it because I found a similar graphic in the Pro Git book, which I honestly find kind of interesting, just to have an overview how you can kind of move between these different states. And yes, we previously talked about git reflog. You can use it to recover committed files or committed changes. You cannot use it to recover stage changes. That's just a limitation. Allegedly, there are also ways to recover stage changes, but this is rather complicated and I've never done it. So at least a colleague of mine has told me that it's possible, but I unfortunately cannot give you any details on that. Because I think he mentioned that if you add a file to the staging area, it creates a blob, and that blob is still there somewhere, and you just have to find it, and it's a bit difficult, and yeah. Anyway, I think I've briefly touched this example. Oh, let me see, we're running a bit low on time, but I'll get over the rest quickly, I hope. You only want to commit, for example, this function A, but not the debug statements that I've inserted. Well, you can do this. You can do a git add with patch or -p on your main. And what it does then is that it opens an interactive dialog. For example, here I have this function A where I've changed something and there's a debug statement down there. I don't want to commit the debug statements, which is why in this question field, I type S for a split, which is basically telling me, oh, please, I don't want to commit it once. Let me selectively decide. What happens then is that I'm asked for this part here. Oh, do I want to state this hunk? What's called for a commit? I say yes. And here I say no. And then we end up in the situation where part of the file are staged for a commit and the others are not. And I find this to be quite useful.
And that's the case when it shows in the git status that it's at the same time staged for commit and modified.
Exactly, yeah. Yeah.
And that means that in the end, I end up if I push this to GitHub, I end up with a different version there than I do on my local file.
Right. And it's a bit confusing.
It still manages to keep things in sync from then on, or
yeah, I mean,
to do that every time I change something on that file.
No, not really, because this debug statement just remains a file in modified state, and with all the same properties as if you would have inserted this debug statements afterwards. After doing your commit. That would be kind of the same situation.
So I think your point was that if I change another thing in the file but still have the debug statement I don't want to have staged, I would have to go through the same process again.
Oh, yeah.
It doesn't keep track that I once from staging, and so
you'll have to do
every time.
Right. Cool.
So that will
make me very soon have a if debug equals true.
Yes, I mean that's true. Like eventually you'll get annoyed by it. That's true. Been there, done that.
A temporary solution usually.
It is a temporary solution, yes.
Nothing you would do permanently.
Or something, another case where you would use it, you say, oh, I have all of these changes, but I only want these few lines in that commit and the other changes in that other commit. So you can do that one after another. Okay, so far about staging, now Git stash, that's the second last part. Another very useful tool of Git is the stash, and I try to visualize it with this very fancy animation. You can imagine the stash a little bit like kind of your desk, where you are a pile of stuff besides your desk. And for example, if you've done a git pull before, you might have run into the situation your local changes to would be overwritten by merge. Might have seen it before, and it says very carefully here, please commit your changes or stash them before you merge. And stash is a very subtle word, but it actually means something quite specific. So what does it mean? Well, what we're trying to do here is to do a git merge. Let's say we are on a current branch main and we have some uncommitted modified files in our tree. And we want to do a git merge and we get this exact error above. So what do we do about it? Because we want to do this git pull, so what do we do about it? Well, we can type git stash. And what it does is basically removes all the files with modified state onto the stash area, which is just like you can imagine as like a stack memory where you have these unnamed commits which have these funny looking strings. And afterwards, well, you don't have any modified files anymore. You can do your git pull or your git merge, doesn't matter. It works. And then afterwards, you can do a git stash pop and restore the state again. And this, the reason how it works is basically what you create is a temporary commit on the stash, and basically you then merge this content of that stash back into your working tree.
I didn't know you could get it back. For me this was a write-only storage.
Oh no. then you might want to try git stash show or list, I don't remember how it is, and see the very long list of things that you've put onto your stash. I mean, that's kind of the point. Yeah, so I hope you learned something today. Okay, so that's basically it. And the last topic I'll talk about are remotes, which I have briefly talked about before. I mean, you cannot really get around it. If you're working with GitHub or GitLab, you will know about remotes kind of, because you want to push your stuff to GitHub. This is what Origin is, right? Yes, and I think in order to explain what Origin actually is, let's try to kind of show what a git clone actually does. Well, we create, let's say we want to clone Liquid to our disk, we create a directory, enter it, and we type git init. Well, what we do now manually is we type git remote at origin. Oh, origin, this is where it comes from. And we say, oh, this origin is at this URL. And then we say, oh, let's please change to the master branch of this repository. And this is essentially what a git clone does. And the origin comes exactly from here. And this is just a default name that Git uses for remotes. And in principle, you can use any other name. And yeah, it's just a default. And in case this is just a thing specific for this example in Liquid, the master branch is a default, just in case you want to reproduce. So why do you want to use different remote names? So of course, remotes are one way of interacting with GitHub or GitLab. You need them in order to communicate with outside of your repository. You don't necessarily need fancy platforms like GitHub or GitLab. You can also just use a machine with SSH access and a file somewhere. That works. Or it can just also, a remote can also be just a different folder on your machine. That also works. I think the more interesting part is that you can have really as many remotes as you like. And this is useful for example, publishing. You have like your private GitLab instance, but sometimes you have your public GitHub repository where you want to push only specific things to. Then you can use multiple mirrors and only push, for example, to GitHub the stuff that you explicitly ask for. And then you would use these different remote names to communicate differently to like, for example, GitHub or GitLab, whatever. And you can use it, for example, to copy something from one repository to another. It's just an example that I'm showing here. For example, we have this project here on GitHub and we want to copy the main branch to GitLab. what we do is, well, we clone this, we go into the directory, we add. And remember that git clone implicitly adds this origin remote. But what we do now here is that we add a second remote with this git remote at GitLab, and this is just a different URL. I mean, it can be any URL that you want. And then we just say git push GitLab main. And in this case, we explicitly have to tell push which repository and which branch to push to, because something funny called tracking information, which we'll get into a moment, which is basically what I'm trying to pose with this question here. Why do I sometimes need to specify the remote, and why do I sometimes not have to? Because, I mean, most of the time, if you type git pull or git push, you don't really type anything else. Well, this is done with so-called tracking information, and you might have seen that with like -u or set upstream or something like that. And basically, when you do a git clone, it automatically tracks the upstream default branch, which is also like origin head is a fancy way of saying, oh, this is a default branch of a certain repository. You can probably ignore that. And for example, if you have some repository on GitHub with a main branch and you do a git clone, it will automatically track origin main, which is just a convenient thing. But you can change it anytime. For example, if you decide, oh, I don't want to work on GitHub anymore, I can just say git branch -u and change it over to a different remote if I want to. And if it doesn't exist yet, this is something that you may have seen before, like with this -u flag during a git push. You can also do it like that. And then you can just do git push and pull normally without specifying anything. This brings us, yeah.
If I push to a different remote,
Yeah.
and then I continue working, and I will git push again without explicitly removing the remote, is it the last remote I pushed to?
No, the one that's specified in the tracking information, and if you specify it like here, it doesn't change the tracking information.
Okay, so the next git push without GitLab main would be the GitHub.
Right. Whoever wants first.
Again, next slide.
Yeah.
What's the difference in checkout and branch? Because usually it's also recommended you can create or switch to a branch.
Oh, well, I mean, the Git branch is a bit confusing here because it doesn't create a branch, it just modifies the current branch. And checkout wouldn't be able to do... can checkout do that? Maybe, I don't know. I don't think checkout can change the upstream, if I'm mistaken.
No, it does not.
Yeah. And we're just changing the upstream here. Peter?
Yeah, do you recommend, because you checked out Git liquid because it's old GitHub terminology, so the main branch is still called master.
Yeah.
And now you said for the new one, we do that to main. How would that work? I mean, is that actually something, would that like create complete chaos if you have like one pushing?
Did I actually do, well, I mean, strictly here, I didn't do the liquid example, so I guess it's fine. But I mean, of course, you can do something like that.
But you wouldn't, right? Because typically both remotes would have the full set of the repository, full copy, everything including the history.
In this case, you would only copy the commits of the main branch. There are ways to copy everything.
Ah, okay.
And if you do it like that, you can de facto rename a branch if you want to.
Okay.
I'm not sure if it's a good idea to do that if you have started in a certain way to rename it, because it will confuse people.
Okay, but that would mean I can basically have my GitLab here internally behind the password, and we do the development on there with lots of branches, merges, whatever. Mm-hmm. And then from time to time, when we want to release something, we can push that main part to our secondary remote, to GitHub.
Exactly, yeah.
And have that have a cleaner version there where we don't want them to see everything we're doing internally.
Okay, so it doesn't push all the history with all the branches.
No. In this case, it only pushes main. There are also... When writing this example, I first wanted to do an example where you copy everything, and that was unfortunately a bit more complicated, so I didn't put it on the slides. I think it wasn't terribly much to type. It was just a very complicated expression that I didn't want to explain because I didn't understand it. Okay, so otherwise I'll go over to the summary. There will be lots of handy things to look up to. I won't go over all the things in detail. This is just kind of as a summary for you. Some of the things I've mentioned, some not, like these git log commands, for example, they're useful for searching your history for certain changes. You want to search a certain file, you use -p, or you use these other two git log search options, which are a bit more specific. Blame is another thing that I didn't talk about, which sounds, of course, a bit offensive, and I guess the inventor also meant it a little bit this way, but essentially what it does is that it shows you a file. Maybe actually I can just show it. Let's say I say git blame on the readme file. I guess it's a bit hard to read here without colors or anything. On the right side on the screen, it's a bit hard to see. You see the regular content of the text file. You'll have to believe that that's the content of the text file. On the left, you can see commit hashes, the name of the author, some date. And that way you can kind of trace back who has created this change. And sometimes that's difficult in order to know who to contact if something went wrong with a certain line or something. So that's occasionally useful. The rebase that we talked about, the cherry pick, is sometimes useful if you just want this very single commit from somewhere else, which essentially does a rebase in a bit more easy. I think most of the stuff that we've done here, we've talked about. The commit -v is basically the verbose commit, which I've shown before, except that for this you don't have to set the configuration. The reset we've also talked about. The bisect is something very useful if you don't know exactly where something went wrong, and you give it two commit IDs. And then what Git does is it starts an interactive dialogue where you tell it, oh, this commit is good or bad by running your test suite or whatever. And eventually you'll run, or it'll be able to find you which commit has actually caused the breaking change. I don't use it particularly often because most of the time other solutions are easier, but really if looking at the code is too difficult because let's say you have a big project with too many lines changed, then this is a viable option to kind of reduce the search space where an issue has been introduced. In general, the man pages of Git are really good. Of course, you have to know what to look for. If you don't know what to look for, then they're useless, right? Something that I didn't know before making the slides is this man page Git revisions, which gives an explanation of what head and all these special terms mean, or certain Git tags or Git commit hashes, how these all work, you can find there. And then, of course, the Git Pro book, which is just on the Git website. You can find it for free. Yeah, for much more in detail explanation than what I've done today.